Today we are going to discuss about another type of Fourier series problem. So this problem I'm going to solve it by using exponential Fourier series, and after finding out the Fourier series coefficient I'm going to represent the amplitude spectra and phase spectra. Okay, so this is the given signal. So you can see that here from minus t naught to plus t naught my amplitude is 1 and remaining my amplitude is 0. So first thing what we have to do is like if you are getting a signal, first find out what is the fundamental time period. In this case I can tell that the time period is from 0 to t, or directly I can write that period is t. Okay, so if period is t, I can write the angular frequency omega naught as 2 pi by t. Okay, so I calculated what is the fundamental period and what is the angular frequency of the given signal. Now let us start solving this problem to find out the Fourier series coefficient. So first I am going to write the exponential Fourier series equation, that is x of k is equal to 1 by t integral over t x of t e power minus j k omega naught t dt. This is what my equation is. Okay, so here what is the value of my time period? Just now we calculated period is t, so I don't want to change this term, it is 1 by t only. Now let me change this limits of my integral. Okay, so here you can see that like actually my signal, if I'm taking this point, I can think that like signal starts at minus t naught, okay, up to plus t naught, amplitude is 1, and remaining period my amplitude is 0. So if I'm assuming this is the starting point and this is the ending point, I can tell that I have two limits. One limit is from minus t naught to plus t naught. Another limit, that is integration limit. Another integration limit will be from t naught to t minus t naught. But I don't want to consider this t naught to t minus t naught because my amplitude is 0. So I can like write the integration limit as only this thing, that is from minus t naught to plus t naught with amplitude 1. That is, this I can change it as the limit varies from minus t naught to plus t naught, x of t amplitude is 1. So this is what I'm getting. Okay. Now integrate this one. So you know that what is the integral of e power minus j k omega naught t? It will be e power minus j k omega naught t divided by minus j k omega naught t. To integrate it, apply the upper limit and lower limit, and I'm going to write the final answer. Actually, I'm going to write the answer in terms of sign. So you after integrating and after substituting the upper limit and lower limit, rearrange your equation in such a way that you are going to get a sine term, sine k omega naught t term. Okay, so how can I rearrange like that is, I'm writing this final answer. It is 2 by t k omega naught, then e power j k omega naught t naught minus e power minus j k omega naught t naught, all divided by 2j. Okay, so this I can write it as sine theta. Yes or no? So in order to get in the form of sine theta, that's why I included all these terms. Okay, so now as we said, this equation I can represent it as 2 by this term I'm going to represent here. So k omega naught t, this entire thing is sine k omega naught t. So I can represent this thing in terms of sine, and this is what my Fourier series coefficient I am getting after integrating and substituting the upper limit and lower limit. So we calculated the Fourier series coefficient of the given signal. Next thing what we have to do is we have to find out the amplitude spectra and phase spectra. So let us start the calculation for amplitude spectra and phase spectra. So I'm just starting with the same equation, whatever we got it from the integral. Okay. So before going for the calculation of amplitude and phase, first let me substitute k equal to 0 and let me find out x of 0. Okay. So why we are going for that is, if you are directly substituting k equal to 0 here, what you will get? You will get sine 0, it is equal to 0. We don't know whether that term is 0 or not, because like actually we said that Fourier representation means you are going to represent as a harmonics of sinusoids. You may be having a DC term, you may be having a sine term and a cosine term, or I can tell it that like you have a DC term, you have an odd part and even part. Okay, like that you have to represent in terms of Fourier series. So we don't know whether we have a DC term or not. So for finding out that DC term, what I am going to do is I'm going to find out the value of x of 0. So in the Fourier series definition itself, we said that how to calculate that DC term amplitude. It is 1 by t integral over that same time period. Okay, integral over whatever the time you have, it is then x of t dt. This is what the DC term equation. This thing you studied as a definition. Okay, so in this case, as we know, this integral is from minus t naught to plus t naught, and amplitude of x of t is 1. So after integrating, what I will get is, I'll be getting it as 2 t naught by t. This is the value of the DC term. Okay, so I think hope you understood why we are doing this calculation. Okay, so we calculated what is the value of our DC term when we are substituting k equal to 0. Now let us find out the amplitude. Okay, so in order to find out the amplitude part, you can see that I don't have any this term. Imaginary term here. Everything is a real part only. So like you know that what is the amplitude or magnitude of x of t? It is square root of a square plus b square, that is real part square plus imaginary part square. But I don't have any imaginary part, so it will be square root of real part square, that is obviously it is equal to real part itself. Okay, so I'm going to calculate my magnitude part. So for this purpose, what you can do is you have to substitute different values for t. Okay, so let us do one thing. We will start substituting the values from minus 3 to plus 3, just like we did for the previous problem. Okay, so first if I'm substituting, k is equal to minus 3, that is capital X of minus 3. Capital X of minus 3 will be here. I have to substitute k is equal to minus 3. You know that what is omega naught value. So I'll do one thing. I'll do that calculation here. So here what will happen is 2 sine k, what I am going to substitute is minus multiplied by omega naught is 2 pi by t. Okay, multiplied by t naught, all divided by k. Omega naught value is 2 pi by t naught multiplied by t. So t naught, 2 pi by t multiplied by t. Okay, so this is what I am getting. Okay, so this t and this t will get cancelled, and this term now I am going to write. Okay, that is, how can I write t naught by t? What is T naught by T? T naught means, you can see in that question itself, T naught is where my signal is on. That is like where I have an amplitude. Okay, remaining time periods and all, like if you are thinking from like the starting of my signal to the ending of my signal, that is from this to this. Okay, this point only we said that it is minus T naught. Okay, so this was plus T naught. This is ending here. So if I am considering this entire T, this is my total time period T. So if I am considering the total time period T, I can tell that T naught means my on time. So this thing T naught by T, that is total time period, is this thing. This is my on time. So on time by total time period, I can tell it as a duty cycle. Okay. So this duty cycle of the signal, can I write it as 1/4? Okay, because only in this time period my signal is on, remaining periods it is off. So this entire thing I can write it as it is 1/4. Okay, T naught by T I can write it as 1/4. So if I am substituting that here, I'll get it as 2 pi multiplied by 1/4. Then this 2 and this 2 here, this thing will get cancelled. So I'm getting it as 2 pi by 2. Okay, this is what I'm getting. Okay, so now if you are calculating the value of this, I'll get it as x of minus 3. I'm getting it as minus 0.106. This is what I'm getting for k equal to minus 3. Similarly, let us do k is equal to minus 2. If I am substituting k equal to minus 2, this term alone will get changed. Okay, so this equation will become 2 sine minus 2 pi by 2 divided by here also. This k also. This here it will be minus 3. Here it will be minus 2. So minus 2 multiplied by 2 pi. So if I'm calculating the value of this, I'll be getting it as 0. Okay. Now let us do for x of minus 1. X of minus 1, if I'm substituting, I'll be getting it as 0.318. Now let us calculate x of 0. Actually, we know already the value of x of 0. Okay. So let us directly move to what is the value? X of plus 1. Okay, x of plus 1, I will be getting it as 0.138 only. X of plus 2 also, I'll get it as 0. X of plus 3, I'll get it as this thing. Okay, so same values only I'll be getting. It is just repeating. So, you can tell that you calculated the magnitude part of my Fourier series from minus 3 to plus 3. Now, you can plot your graph. Okay, so before plotting, actually we said that what is the value of x of 0? X of 0 is 2 t naught by t. Just now we calculated what is the value of t naught by t. T naught by t is 1/4. Then this thing will become 2 multiplied by 1/4, that is equal to 1/2. Okay, so this is the magnitude part of x of k at k equal to 0. So I got the value of x of k at k equal to 0, k equal to plus 1, minus 1, plus 2, minus 2, plus 3, minus 3. Now I can plot the graph. So hope you have clear this thing. So once again, I'm just telling how I can start this thing is like actually we are getting, this is the equation we are getting. Okay, substitute the value of omega naught. Omega naught is 2 pi by t. Okay, here also substitute the value of omega naught 2 pi by t. Then you just substitute what is t naught by t value. T naught means my on time. T is my total time period. So I can write it as 1/4. Okay, so this 1/4 substitute here. Then your entire equation will become 2 sine k. Here it will be pi by 2 divided by, here it will be k 2 pi. Okay, then keep on substituting different values for k. Okay, so this is what you are performing for the calculation of magnitude spectrum. Okay, so let me plot that. So you see, Actually I plotted the magnitude spectra. So you can see that like in the we already calculated the values from -3 to +3. Like, so whatever the values we calculated, that only I marked. At k is equal to 0, we got it as 1/2. That's why I marked it as 0.5. At k equal to +1, it was 0.318. This side also 0.318. At k equal to 2, it is 0. Here also 0. At k equal to +3, it was -0.106. And here also -0.106. And at -4 and +4, again you will get it as 0. Okay, so this is the like the points you are getting. So if I'm drawing an envelope over these points, I will get a waveform like this. Okay, so this waveform is known as sinc function. Okay, so sinc, S-I-N-C. Okay, this is known as sinc function. What is sinc function is, if I am representing sine theta by theta, that is known as sinc function. Okay, so how can I represent? So this is my equation. So after calculating the Fourier series coefficient, this was the equation we got, isn't it? 2 sine k omega naught t naught divided by k omega naught t. This was the equation we got. So how can I represent this thing in terms of sinc function? Is actually I need as sine theta by theta. Here, what is the theta value? Theta value is k omega naught t naught. So I need to get that thing as in denominator also. That is, I have k here, omega naught also here, but I don't have t naught. I need a t naught. Then only I can represent it as sine theta by theta or as a sinc function. So what I'm going to do is, I'm just multiplying a t naught here. Okay, so this t is extra. So take this thing outside. So I can write it as 2, that extra t naught to represent a sinc function, then this t, then sinc of k omega naught t naught. Okay, so this equation I can rearrange it as a sinc function. So this is how we are doing we are plotting the magnitude spectra. Okay, so let us now move to the phase spectra. So already you know that how can we calculate the angle or phase? It is tan inverse imaginary part divided by real part. But you can see that in this equation, do you have any imaginary part? No, we don't have a term with j. We don't have any imaginary part. So this imaginary part, that is numerator, will become 0. Tan inverse of 0, it is 0. Okay, so we have only magnitude part for this, and this is the magnitude spectrum, and phase spectrum is 0. So this is how we will do this kind of problems. Let us see one more problem. Okay, so this is a third problem. Okay, so you can see that this is the graph which is provided. Okay, so we are going to do this problem by using exponential Fourier series itself. So you just see what is the total time period here. This side, minus side, you have t. Here also you have t. You can see that the signal starts here and end here, and again it is repeating. Okay, so you just think it as this line as a full stretch. Don't think it in this way. Why I am telling like that is, like if you are thinking in this way, that is like it's starting at this point, going like this and ending at this point, then you may need you need to integrate 2 times. You will be having 2 limits, one from 0 to t, another from this t to this point. You have to integrate it full. Okay, 2 times you have to integrate it. But if I am calculating my signal starts from here and ends here, means I can do this thing as a single integral. Okay, so we'll see that and you will understand that. So first, let us see what is the period of the signal. I can tell that period of the signal is equal to 2t. Why? Because this is t and this is also t. T plus t, it is 2t. Now, just write what is the angular frequency. Angular frequency is 2 pi by t, that is 2 pi by 2t will come, that is pi by t. This is the angular frequency you are getting. Okay, so that also I am writing, it is pi by t. Now, here in this question, they have not provided what is the equation of the given signal. So let us write the equation of the given signal. I can write that x of t is equal to, you just see, this is at minus t, my amplitude is minus 1. This is at 0, amplitude is 0. This is at t, my amplitude is 1. Can I write x of t as t? You can see here. At minus t, amplitude is minus 1. At 0.5 t, amplitude is 0.5. At 0, 0. At 0.5, again 0.5. At t, again 1. So can I write x of t as t? And it varies between minus t and plus t. Okay, so this is the equation of given signal. Minus t to plus t. So we wrote what is the equation of the given signal. Okay, so that is why I said that please consider your signal from this point to this point. So I can integrate with one equation alone, that is x of t value is t alone. Now let us go for the calculation. By using exponential Fourier series, I can write that x of t is equal to 1 by t integral over t x of t e power minus j k omega naught t dt. This is my equation. Here in this case, my total time period is 2t. So substitute it as 2t. Now, integration limit I have to consider from minus t to plus t. So please write it as integral from minus t to plus t. What is the value of x of t? X of t is t. So t multiplied by e power j k omega naught t dt. This is what I am getting. So how can we integrate this thing? So this is integral uv formula, that is how to integrate this thing as 1 by 2t. Okay. Then first function, that is t. This is my first function. This is my first function and this is my second function. First function multiplied by integral of second. What will be the integral of second? E power minus j k omega naught d divided by minus j k omega naught, and you have to write it as limit. It is varies from minus t to plus t. So first function multiplied by integral of second minus integral of differential of first function. What is the differential of first function? T's differential will be 1. So differential of first function multiplied by integral of second function. Again, I can write it as minus j k omega naught t divided by minus j k omega naught dt. So once again, you have to integrate this portion. You can take it this thing outside and you have to integrate it. Okay, so complete the integral and apply the upper limit and lower limit. So after integrating and substituting the upper limit and lower limit, I'll be getting the equation like this. Okay, so here I substituted the upper limit minus lower limit again plus the another integrals, upper limit minus lower limit. This is what I am getting. Okay, so you are like, after that you can see that like what I did this, like I substituted the value of omega naught. In the starting of our problem itself, we calculated what is omega naught. Omega naught is equal to pi by t. Okay, so that I substituted here. So this t and t will get cancelled. So I am getting here if everything is same except e power minus j k pi. Here also e power j k pi. Everything wherever I have omega naught in this e power term, everywhere I substituted pi by t. So I am getting this equation. Now you just see, if I am taking this minus t outside, am I getting a cos theta form? You can see that e power j k pi plus e power minus j k pi. That is, we can write this thing as minus t, I already took outside, minus t, then 2 cos k pi. Okay, so this term, this entire term, I'm going to substitute it as cosine term. Similarly, this term you see. This term, if I'm taking this minus outside, you can see that I will be getting it as e power j k pi minus e power minus j k pi. That is, it is in the form of sine. So in order to represent, one extra 2j will come. So like this, we can represent. Okay, but here you can see that it is sine k pi. Sine k pi or sine this thing is 0. So this entire term will become 0. So I can write my final equation as these two things will get cancelled. So I can write it as x of k is equal to minus cos k pi divided by j k omega naught. In order to cancel this minus, I am taking this j to the numerator. So this I'll get it as j cos k pi divided by, I substituted what is the value of omega naught. It is k pi by d. Or I can write it as this t, let it go up numerator side. So j t cos k pi by k pi. So this is the answer for x of k. Okay, so here also do one thing. Like we don't know what is the value of Fourier series at k equal to 0. So do the DC term calculation, that is, calculate what is the value of x of 0 by using the integral 1 by t integral over t x of t dt. Calculate it. Okay, so after calculation again x of 0 you will get it as 0 only. So you can tell that the answer x of k is jt cos k pi by k pi. Okay, where k not equal to 0. Okay, so I can write my final answer as, x of k is equal to j cos k pi by k pi for k not equal to 0. If I am substituting k equal to 0, x of k is 0. Okay, so this is the answer you are getting, or this is the Fourier series representation you are getting for the given signal. Thank you.